Just hold 1 second. I'll get everything back up. Okay, so last week we started with how to fine-tune an open source model. And we started with pulling down the data set that we wanted to fine-tune with. So the first part was about figuring out what data would train a model to do something different that you wanted. So we used Reddit. We used an Ask Reddit about psychology. And I created just a short script that would take the Reddit commentary, took the first 1,500 Reddit posts and the 5 top responses to each of those posts, and built just a database out of that, and then converted it to the ChatML format, which is what LLama models use. So different models use different formats of data. And so we went through that and converted that into data that could then be used to train the model with. And we're using the GPUs of the university to do this. So I'm on the large cluster, which I learned actually gives you 4 GPUs. I thought it was just 1 at a time. So I have a cluster of 4 GPUs running. These are NVIDIA V100s, I believe. And that will allow for the training to take place, though the training takes much longer than we'll get to in the hour here. So when I've been training like 8 billion parameter OLLAMA models, or llama models using OLLAMA, it takes about 5 to 6 hours, even on a cluster of GPUs to train. So you want to set times. So when you go in, you get into the queue to get access to the cluster, set enough time if you're planning to train. I've made this mistake. Like I set 4 hours and then I set it to train and it gets halfway through and then my access to it goes away and it stops when that happens. So now the good news is when I go in and I set it for like 24 hours, it doesn't take that much longer than when I set it for 2 hours to get into the line. Now at different times of the year, like my guess is if you get like towards the end of the semester and more people are using it for bigger runs, then it may take longer to get access. But for now, it's like you wait a minute and then you have 24 hours of access to it. You can do up to 7 days, but I've never had reason to request for 7 days. You had a question?
Yeah, how do you have a sense when you're first doing this of how long it's going to take?
I think there is, so they mentioned this at the HPC meeting the other day. So when I go in through command line, I do sinfo space -a, and that tells me like all the availability. And it tells me which ones are idle, which means they're open, and which ones have space and which are allocated. But I think there is a way too, you can see what the allocation queue is. But you can only go so far because what you don't know is like, is it allocated for 10 hours or for 15 hours? You would have to probably get into like the whole Slurm directory to figure out, and then try to calculate, because it has like a very complex calculation of scheduling to figure out like, oh, you want 4 hours of this number of GPUs on this node. How can I best squeeze that in among someone who has 7 hours and someone who has 10 hours?
I'm asking about the
Yeah.
orchestration as much as the like when you're designing what you want to do, how do you scope it so that it's going to be a small enough job?
How do you know it's only going to take you 8 hours and not like 3 weeks?
Oh, only through doing it is, I mean, I haven't found anything else other than doing it.
Okay, so you just did it and you hoped, and then the first one happened in 6 hours.
Yeah, so it does show like when it starts running, and so then you can see, and then I just look back when it was done. I was like, oh, that took 4 hours to run.
So it'll tell you at the beginning, like this is going to be, it'll give you an estimate.
No, it won't give you an estimate, but it just gives you the percentage. Yeah, so, but I guess it doesn't know like how much resources you have, and your resources change as you're training. So like, as it uses up more, it might slow down for parts of it. And you only have so much RAM. I guess it could if you gave it like how many chips, how much RAM each of those had, how many cores each of those had. It could, but it would be a complicated calculation to figure out maybe. Yeah, mine's just trial and error. We can ask the computer science people, they might know. They do those types of things. So let me go ahead and trying to get to my menu system there. It keeps giving me my main menu. Oh, does that work there? So if I go into there. So as I mentioned last week, you want to, if you're using the system, you'll want to use the Scratch folder to store your stuff. That's not good. That's frozen, it looks like. So I'll go in this way. Okay, so here we were from last week. So as I said, I created a data set maker, and you can watch last week's video to see how that was done. It created a JSON file that I then converted over to this chat ML format so that it would be fine with that. And then we are using unsloth to actually do the fine tuning. So I guess for those who maybe are less familiar, so we're going to use something called a LoRA process for fine tuning. It's low or least something or other. I don't know. What it does is it doesn't fine tune all the parameters. It calculates which are the best parameters to fine tune, and then it gives you new weights for those parameters. And then it builds the model off of that. So the first step is I'm using this software called Unsloth, which will actually do all those calculations to figure out what are the parameters that should be changed from the original model to be fine-tuned with the data that I've given it. So, yep.
Does it fine tune only closed models? I mean, only open models or closed them?
Only open models. Yeah, I believe. Yeah, it would only be open models.
Open weight.
Models that you have their weights. Yeah. So like ChatGPT won't tell you what their weights are, so you wouldn't know what to fine tune anyway. And so basically, and you could do all of this through PyTorch on your own, but this Unsloth takes care of a lot of that for you, which is nice. And it's an open source package. Now, the one problem with it is that it uses other packages, so there's a ton of dependencies, and they don't always work real well. So you have to do some troubleshooting sometimes, because a dependency package will update, and then they have to update. And we're going to run into that problem when I run this. So now that I'm in, though, what I have to do first is, since I just got back in and I didn't have my environment set up anymore, so first thing I have to do is go in and recreate the environment that I was working in last week. So so it doesn't have anything on it when you go into the clusters, when you use HPC. So the first thing I'm going to do is install Python so that I can use Python. And then I'm going to install Ollama, which is the tool that I'm using to work with open source models. And then I'm going to go ahead and start up an instance of an Ollama server so it has some place to run those models. And now if I do Ollama, give it a second to get my. So if I do Ollama list, so these are the Ollama models that I have available to run. So as you can see, I'm running, or I have access to a DeepSeek 8 billion parameter model that I can run, which runs really nicely, by the way. They're good models. This is the one we're going to recreate today. This is my test version, one of many test versions, but this is the one that's still there. Actually, I have several left there. Then I have some models that I trained back in June that are still sitting there. And then the original Llama models that I'm training off of. So you have to download the original model that you want to train to fine tune. So you have to have a copy of the model. So if you go to Llama, then you put in, like, you can see the models. This is right now set up to be by the most popular, and these are all the models you have available if you want to use Llama for your fine tuning and for running your models. There are others you could use, but I'd say Llama is definitely the most popular. Yeah,
Is
of course.
Mama just like a Hugging Face alternative?
Kinda, though you can run Hugging Face models in Llama. So yeah, so you can run like on my computer, if I want to run an open source model of my own, I would just well, I have Llama, but you would download Llama package. And then when it's running, you can install it. And then you just like put Llama run and tell it which model you want to run. It will, if you don't have it already, it will download it and run it for you. And then you can just start using that model through the command line. You can also run a user interface for it real easily. Like if you want to have like more of the ChatGPT experience, but you want a model running on your own computer, Llama does that for you. While Hugging Face does not. Hugging Face doesn't have like a software that you would put on your computer to actually run the model. They just store the models and let people do things. And Hugging Face is great for what it does. It just does something slightly different.
Hugging Face is just a library. Llama is a library plus serves you what you want. You can help you.
Yeah. So, and right now I'm just running it on someone else's computer because it runs better. On my own computer, I can't run like the 8 billion parameter DeepSeek model without long delays. I can run the 7 billion though, which is kind of odd to me. That's only a billion difference. But I have an M2 chip on this. It's all right. If I had an M3, I could probably run bigger models. But it runs pretty, I mean, there's like a 15-second delay and then it gives me the output. So I still use ChatGPT because it is faster and stuff like that. But for running your own model, like if there's things if you were running a research thing and you didn't want to share data with any other place, you just wanted it on your machine, you could do a small model on your own, or you could do what I'm doing here and just run a big model on their GPUs. So you could fine tune a bunch of them, run data through, do simulations, and then pull all that data down. So yeah, so what we're going to do, I'll show how it runs later, but I wanted to show through the code real quick of the fine tuning. Again, most of this, I'm just pulling and using whatever their defaults are. I don't really know what a lot of it means, but that's fine too. So these are the models when I downloaded these were the models they had available. You can go to the Onsloth website and they give you a new list. But pretty much the first thing you do is you tell it, what is the model you're trying to fine tune? So I tell it, I want to fine tune the Llama 3 8 billion parameter model. And specifically, I'm using a 4-bit version of that. So it's been quantized down to 4 bits so it can run faster. You wouldn't have to, but it just speeds things up. So I tell it down below then that I want everything to go in as a 4-bit compressed type thing. Then there are a bunch of settings. I have no idea what they mean, like the Q project, the K project. They have fairly good documentation. So if you were curious about any of this, the challenge for something like that for me would be like, if I set my alpha to 15 and then spent 5 hours waiting for it to train to see what the difference is, it probably isn't going to be significant enough that I care. But I'm not trying to optimize for anything either. Like if you were trying to optimize, you might make some changes to all of this. So then I tell it what type of data to expect. And I said I'm going to use the ChatML format. As you can see, though, there are lots of other formats that they support. Alpaca is a pretty common one, too. And then I tell it how to map the different components. And all of this they have again on their documentation. So if I switch to Alpaca, I would just switch my mapping as well. And then it talks about tokenization, and then I tell it where to get the data set that I want to run. I'm just going to run on 200 of the top posts rather than the 1500, just because it will run faster, just having to go through 200 of them. A bunch more settings. Again, I don't understand what a lot of them are for or why I would want to change them, so I just leave them at the defaults. Yeah, and then that's pretty much then to do its part. Then to use it with, so I'm getting it for Llama, it uses files that are in the GGUF format, whatever that stands for, I don't know, but that's what it runs. So any files you download into Llama will be in the GGUF format. So I'm making sure at the end that it is in that format so that it should all be read fine. So now I'll go ahead and run this. Oh, let me activate my environment. Make sure I'm in my right virtual environment. Okay, then I want to go to my directory. That's not the right one, is it? Oh, there we go. Edit, paste. Okay, so let's see what directory I'm in. And I think I actually want to be in a different directory. So let me go up a directory, ls. Yep, there I am. That's where I want to be. Okay, so once I get into my right directory, then I can go ahead and run that script. And this is what I did right at the very tail end of last week. So then I did Python coders demo fine tuning. And this will just start to run. This part takes like 4 or 5 minutes to run. And what this is going to do, in the end, it is going to, if I go back to my directory, it's saying create a folder just like this. It'll actually replace this one because I didn't rename it like I should have. And then this is all of the essential information for how to customize the model. So these are actually these safe tensor files that are these files of like, I don't know, 20 gigs over here. Those are actually the weight files for what has to be changed. So that's the key information so that it can apply the new weights to the specific areas within the model. My understanding is it does anywhere between like 1% and 10% of the model weights get changed when you use this process, depending on what you're fine-tuning, what data you're fine-tuning with, which model you're, and all of that. So it's going to update some percentage of those. I guess as the percentage goes up, it probably takes longer and longer to actually do. But that's basically what we're building. And this ran on the 23rd. So this is the one we actually ran last Thursday. Yep.
I see here you're using the GUI. So is this like the on-demand, or can you run it like using the scheduling? And I guess the high compute, they say like you have to schedule it with a batch file.
Well, you can run on demand like through the command line too. And you can put it into the queue to run later. But you can also just do the same thing through the command line. Like once you're given a node, you should be able to run it without having to queue it.
But
I am using the on-demand process, but my understanding is you can get the same out of it. But yeah, you could run it as a batch if you wanted to, if you didn't want to run it immediately.
do you often use the on-demand like this when you?
I find it easier. I find some of the visual interface stuff easier. I can use Linux, but like if I'm copying and moving files and changing directories, I'm likely to mess it up somewhere. And so it's just easier to drag and drop. And then since it's on demand, then I can just keep running things like this. So if I know, like when I was training a bunch of these in preparation for doing this, I would just do them like at 10 o'clock at night, hit it, go to bed. And in the morning, it would say it was, well, in the morning, it would say it caused an error. And then I would do it again the next day. And then until I got it to finally work right. And again, it's like anything with code. It runs sometimes really well. A lot of times there's almost always going to be some type of error that comes up. So the error that I know will come up at the end of this, it will go through and it will figure out a lot of that. So this uses a package. Yep.
What node are you in right now?
This is the large cluster. So this uses. So Unsloth uses this llama.cpp, which is a whole another set of packages for working with open source models. And what will happen, the error I will get will say, if I'm using the newest, if I have this newest llama CPP, it actually is going to cause my Unsloth not to work. So I have to actually, to get it to work, I have to go in and I have to go to a prior version. And they're working on this. I looked it up. It was on, they have a GitHub issue for it. It's like 10 days old now. And it says we're working on this so that you won't have to. But the Llama CPP people updated in December, which caused this. They deprecated some terms and then it caused all these issues. And these are all open source packages. So it just takes time for people to get the updates done. So I know that this is actually going to crash, but here you can see it's going through and creating all of the different weights. But since I know it's going to crash, I'll just show real quick how you go about doing that. So I'll stop this task from running since I know it's going to be problematic. Yeah, so what I'll do is go through a quick series of commands. So I'll go into, oh. Yeah, oh, maybe I did. Yep, go. What I'm going to do is actually go in and install the prior version of it, and then everything should run fine. Hopefully in a week or so, this won't be necessary anymore because they'll have figured out how to fix this bug in the system. Oh, no changes. I think I know what I did. I think it's picking up when I copy paste, it's picking up a space. Yeah, so now it's just going to, it installed the earlier version of that. And so I'm going to go ahead and install the submodules that I want to get around this problem that it has. And then this package is actually, you have to make it, so you have to unpack it basically so that it can run. So I'm just putting in some commands, again, that I just copied off some discussion board online, and it works to actually build the new version of the CPP package so that I can then use it without getting that error message. And the only reason I'm showing this too is because I'll share my code and you'll end up with the same error and you'll go, oh, why is that? And then this will show you how to fix it. Give it a second to do its thing.
I have,
Yep, of course.
so if I understand, first we're using LLM to download a model, run a model, and then after that we have LoRA to fine tune. Wait, earlier you had mentioned some other package, something open source in between, before, something to do before LoRA. What was that?
So, oh, well, we had to get data to train against. So that's what we did to get the Reddit data and then convert it to the right format so that LoRA could create weights off of it. So it has to be in a comparable format to the model that you're trying to train against.
So that's like a translator. So
Yeah, it will help. Yeah. So, and it's just a formatting thing. I mean, it's the same data. It's just what type of JSON categories it has within it. And different models are expecting different types of data based on whoever created it in the first place, and what they had it set up for its original training. Okay. Of that, so it's just a script that I ran. It's just a Python script that just changes the format of the JSON to make directory. Oh, they already did that one. Okay, two more lines, and then this will all be updated. So this is one of the kind of pain things that happens, especially when you have very new things that people are changing a lot. So this is just, again, rebuilding that Llama CPP, and then it'll use that to create the weights in a format that will work for the GGUF, which is what's the problem that the error I kept getting. I would install it and it would say it didn't have the right files for the GGUF package. Goes, now it's going fast. Okay, so now we have all that is updated and we're back to where we were. So again, now what we have is we have in here, we've created this directory and it has the weight parameters that we want. And these are the ones we want to apply to our model. So in order to do that, then, so what might be easier is actually what I'll do is I'm going to go up a directory level. And here I'm just saying create a new folder. Oh, well, let me create a new folder here. I haven't done this in a while. So just to make it easier to figure out where the different files are. Let's see if I can open this. that's not working. Okay, so that's. Just give me a second. I want to see where I am. Oh, I'm still in there. Okay, so since it won't let me create a, well, I guess I could just make directory here, couldn't I? So let's do make directory, and we'll call it GGUF model. Now, if I, do I have a, yep, so I have a directory there. And what I'm gonna do is, and again, this is more probably for convenience than that you would actually have to do this. I want to go ahead and move. I'm going to make sure that all my files are in the right format, and I'm going to move them into a folder so that I can have them in one place, which would just be easier to work with then. So I'm going to go back into the Llama CPP, and I'm just going to tell it to use Python to convert the Hugging Face over to the GGUF and put them in the right spot. Oh, actually, this is going to be. Have 2s there instead of 3s. Then I'll run it. So again, I'm just making sure everything is in the same GGUF format, the tokenizers and all of that, so they can speak to each other. And once this is done, then we're actually, I think, fully ready to start the fine-tuning process, which I will start, but then we will actually look at one when it's complete because it takes, again, quite a while to do. So the file, it looks like, is 16 gigs that it's moving over now that it's changed it to the right format. Okay, so if I do CD S, then if I go into GGUF models, LS, you can see now I have that psychology model, which has all those weights and stuff that we want, and it is there right where I want it. So kind of 2 new steps for this. One is you have to have a model file that tells it what to do, which is kind of like a YAML file to tell it when you want it to fine tune what parameters and stuff you want to put in with that fine tuning. And as you can see, so I put it into a separate folder just so it's easier to see. I have the file there, but I don't have a model file to tell it how to fine tune it. So I could set it to fine tune like with different temperature settings or top P settings, and it would fine tune against those settings. So what I want to do then is get that model file, and it should have been created by Unsloth, so it should be sitting in that directory. So if I look at my directories in that psychology _1, 2, 5. Why is there not a model file there? There is not one there. Thought it would have created one. So I'll just go ahead and create one. So if I go to, I'll go back into that directory where my models are. And I will, I believe it's just like that.
So
Yep.
with GGUF, you convert the safe tensors to GGUF or wrap everything, all the files associated with the model to a single file?
Yeah, I wrapped all of it together. So it has the, well, it has the safe tensors all put into the GGUF file. Yeah, so it's all moved to one basically. So actually what I'll do instead of doing it that way maybe is I'll just go ahead and open this one. And then I'll just resave it. That might be easier. So this is what that YAML type file says. It says, this is the file you're going to use. This is the template for how conversations, and like here I set a parameter. I set the temperature to 0.5, but there's a list on their website. You can set other parameters. And what I'll do is I'll just save that into the other folder. That will go faster than rewriting it. Okay, so now, let's see if I go sit down here. So now if I list, yep, the model file is there. And I'm in the same directory. So now what I want to do, and I guess this is where the magic happens that I don't always understand what it's doing, but so I'm going to use Olama to create a model that I'm going to call Olama Psychology Model, and I'll update it with today's date. So the 30th. And then it's going to use the file, model file that we have right up there to tell it, to tell it what to do. So, and then when I hit enter, it starts doing this, and this takes hours to do. But the output will then be a file when I go to Olama list that is the Olama psychology model 13025 that will show up in my Olama that I can then use and apply. So again, it will take a while to do this. This first part takes like 2 minutes usually, and then it'll do the next part, and that's where you'll get the percentage, and you can see like I'm 1%, I'm 5%. Come back, have dinner, go do things, you're at 7%. And then all of a sudden it'll jump to like 90%, and then it'll be done. But it can take a while. It actually stores it in these 256 encrypted files, which is important to know because like if I remove it from my list of Olama models, it doesn't actually delete it. So it's sitting there at 16 gigs somewhere. And if I go to find it, it doesn't call it by the same name that Olama does. It names it by this. So when I go into my directory, it sits in, it says in their documentation where it sits, but like you go into your home directory and you go down and you'll find a folder that has all of these in it. So, and if you've done a bunch of them, it's like 16 gigs, 20 gigs. It adds up over time. So you want to be able to delete those. But they'll be named with this encryption number, which is kind of too bad because I didn't copy down what the encryption numbers were. So I don't actually know which ones to delete. So I just leave them for now because we have terabytes of storage for free on here. But it would be nice if they named them so I could just go. So if you're thinking you might want to get rid of them, looking back, I would probably copy and paste that and put it in a folder and say, this is the encryption code for this file so that you know which ones to get rid of later on. Since this is running and then you can see we're at 1%. So it will not finish in the time that we have today. So I'll go ahead and just stop it. And you'll just have to believe me that when it gets done, it will just add it to this list of models. But if we want to see, and again, this is the one I just ran 3 days ago, it says. So if we want to do it, then we can llama run and tell it which model I want it to run. It'll load up that model. So now it's just loading up the model so that I can use it interactively. See, even with GPUs, things can still take a while. There it goes. Now I can send a message so I can go. So again, this is trained on psychologist type things. So it was more just for example. So like, why do I feel anxiety? But as you can see, does it say up here at the beginning? So often when I ask it things, when I have it like this, it'll say like, as a psychologist, I say blah, blah, blah. And I didn't have to put any of that in the prompt, like the system prompts or anything. It's because it is trained and it knows. So even though I don't like the analogy, it's kind of like giving your model a new personality, though it's not, they're a model, they don't have personalities, but that's kind of how it feels. Now, is it more accurate? Like, would I go to it for my mental health concerns? Probably not, because I know it's trained off of Reddit people answering, which probably weren't really psychologists who were answering. They were just people who are on Reddit posting a lot.
Wants to be psychologist.
Yeah, I mean, who knows? I didn't even look to see like what were the top 1,500 questions that people asked. Were they even about psych? I mean, they might have been like, where should I go to grad school for psychology? Not about like, so you would want to clean your data a lot better. But people are doing some really cool things. There's a group at Stanford that created 1,000 different people that then you can use to run like experiments on, and they're each trained. They had 1,000 hours of interviews with 1,000 different people, or 100 hours of interviews with 1,000 different people that they then used and trained separate models on, so that then they could have a sample size of 1,000 to do like internal validity testing and stuff like that, which is very cool.
What would that be used?
Well, like if you're developing an assessment in psychology, the first thing you have to do is make sure that if different people take it, the items hang together. And usually you have to get a large sample of people. So they like would go to MTurk or something to get 1,000 people to take it, so they could just see statistically, like if people answered like this on item 20, they should answer like this on item 25. And if they don't, then you know you don't have internal consistency around the constructs. But that all costs money and time, and a lot of undergrads do a lot of these assessments over and over again because they had to have it to get their statistics. So now you could use this program and have 1,000 agents take your thing and then look at, now they're not real people, so they won't tell you how real people react, but it would give you an idea, like, do items stick together like they should? So yeah, what then I can do, and David asked last week, like, what am I doing to evaluate any of this? And it's just like, what I do, because again, I'm doing this for fun, I'll ask a series of questions to the one I tuned, and then I'll ask the same questions to the untuned model. So if I do then I can also on the list. I can then take my untuned model and I can run it. And ask it the exact same questions and see how the responses differ. So yeah, And you can do this, again, you can run this on your computer. I'm running the DeepSeek model on my computer and it runs okay. Not nearly this fast. Like I hit enter and then I wait. I count to 15 and then it starts answering typically because I'm not on GPUs. But you can also build a real easy doc. So there's something called Web UI, which is a free open source user interface for chatbots. And you can just run a Docker image of it. And then it's, instead of going command line, it's like being on ChatGPT and it saves it and you can, I can actually, it's open on a tab here, now that I think about it. Yeah, so this is DeepSeek's, the 7 billion parameter model running on my computer. And what did I ask it? What were the, I was demoing it for someone, so this wasn't, I'm not doing anything about the French Revolution.
I was asking for a friend.
So, what were the consequences of the French Revolution? So this is, again, running on my machine, so there will be this pause.
I love how you know that stuff.
Yeah,
Like,
life is
they
so
understand
grand.
what you mean. Like, that's how.
So this is the delay I was talking about if you're running on your own. Now, DeepSeek does the thinking because it's a reasoning model. And so you can actually see, I want to say it's logic, but what it is doing to come up with the answer. What I haven't figured out yet is how I want to use that information, but it seems very valuable for doing other things with. But I don't know what I would want to do with it yet, but it's pretty cool to be able to have it. So now with DeepSeek, at least with this model, it almost always answers in bullet points and sub-bullet points. But again, that's a system prompt, probably somewhere tells it to do that. But I could update the system prompts for it. And it's mine, it's sitting on my computer, so, which is really nice because I don't have to use anyone else's. So if I wanted to do something with student assignments, I could feel comfortable doing it because it's just all residing on my machine. And the results are pretty amazing. I mean,
What would be like a package we can install so that it can also browse the internet?
beyond what I've gotten to so far. I'm sure it does it because everyone uses, I mean, you'll go to a lot of chatbots now and they all use the same user interface. So I'm sure from the user interface side, it's not that hard to add that feature. But I don't know. Running on my own, I'm not running it on a server, so it would probably be different if I was running it like on a web-based server, but I haven't done that yet, so.
So you said web UI?
Yeah, this is called Web UI, and it's just running. No, not there. Oh, I think I'm just sharing the browser, so you may, yeah. Oh, sorry, this is something. The icon was similar. I was looking, let me stop sharing, and I'll just share my screen. So it's just running, it's just a Docker image. So I downloaded it and just opened up the Docker of it, and then it gave me a port, and I'm just running on that port.
You
So
made
this
this
is-
Docker, or was it available?
Oh yeah, yeah. And I can post the video. There's a video that shows how to do this like in under 3 minutes.
That would be great.
Get this up and running. And then it's running, it should have, it has any of the Llama models that are on the machine. So the ones we have over here is my longer list because I'm running on the GPU for that. This one is running actually on my computer. So I only have 2 models on my computer. And I don't even remember what the Arena model is, but the DeepSeek is the one that I've been using. And if I could add other models, so I could have like 5 different models. They're running the same thing on GW computers. So if I come over here on this Hades server, they're testing out a bunch of different models. And so this model list changes all the time as they try different models to see for different projects how they're going to interact and work with their hardware and stuff. But that's how I learned about the web interface, and then I went to that. So all in all, it's not that hard to fine tune a model is what I've discovered. Again, I don't know what all those parameter settings are. I'm not worried about efficiency, all those things that if you are running a real project, you would have concerns with. But if you just want to get a model up and running, you want to fine tune it for some reason, I don't know, maybe you have 1,000 blogs of your own you've written and you want it to be you and have your responses. It's not that hard to do. I can think of 1,000 like social science research applications. So I'm very excited about that. Again, like the psychology, having bots take assessments rather than people for creating stats is really helpful, I think.
What about like, not research, but like, what about like, so taking these models, fine tuning them, and then like on a practical maybe business application, somebody building these plans.
Yeah, probably. So I'm working with 2 teams in the data science capstone course that are doing multi-agent systems, and each of them will be fine-tuned to do different things. So like they're using Crew AI, which is an open source package for easily creating multi-agent systems. So you have one agent, and then you have your crew of other agents is the metaphor. And you can fairly easily start up a multi-agent system. So, but if you're having multiple agents, you want them to do different things. So you want them to be fine-tuned to do those, or you could RAG them to do different things. But RAG just does something different than fine-tuning does. RAG is, my current analogy, I haven't found a great analogy, is RAG is like giving your AI a book. You're just giving it another knowledge source that it picks apart and pulls pieces of. Whereas fine-tuning, you're actually like giving your agent a new personality or hiring a new assistant that just is a different person. It does different things. Will do some things well, do some things poorly. But it seems like a really powerful way to use the models in interesting and unique ways without just going to people's websites. Running your own model, I think, is probably the wave of the future for a lot of applications rather than relying on sending all your data to Google or to OpenAI so they can use it for other purposes.
Class.
Oh. Okay, you're gonna turn us off from up there. I'm gonna stop the recording too.